Potential and kinetic energy. So here are some important vocab words at the top here that I'll try to identify and kind of bring out for you because they are really, really important. So some vocab words here. Potential energy is stored energy. So basically it's the fact that you can move, the fact that there is the ability to move, but you are not moving, right? So you're basically still. Ball at the top of a hill. It could be if you're racing someone and you're standing at the starting line and then they say go, the fact that your potential energy, you're not moving yet, but you can move. Gravity, the force that pulls things down toward the center of the earth. We discussed that, last year. And then kinetic energy is energy in moving things. So let's start here. Potential energy. Potential energy is stored energy, right? So that means that it's, again, not moving, it's stored up. Potential energy is when an object has the potential or ability to move, but currently is still. So meaning it's not moving, it's still at this point, okay? The flask sitting at the top of a counter has potential energy. So here's the flask they're talking about. So it could move, but it's not moving, right? It's sitting still. So again, here's our definition, and it's also at the top. It's stored energy. This could be kinetic energy, right, the flask, if a force comes to it. Once it moves, the potential energy changes to kinetic energy. Objects can have different amounts of potential energy. The flask on top of the counter here has more potential energy than the book sitting on your desk. The reason for this is because the flask can fall a greater distance at a faster rate because the counter is at a higher distance than your desk. Since it is higher, the flask will move more potential energy than your book. So here's what they're saying to you. This counter is much higher than your desk is, right? And so your desk, you have at this point, right, in COVID, you have your Chromebook on top of it, table you're sitting at, wherever you are at home, and it's going to be lower, right? So if you think about the countertop in your kitchens at home, that's at a higher level than your desk that you're sitting at. So your Chromebook, your book has potential energy because it can move, but it has less potential energy because it's closer to the ground than this flask is here. So this is what is potential energy, right? So you're going to put your text here and you're going to answer that. You can use stored energy from here, or is when an object has the potential or ability to move, but currently is still. Either one would be fine to put in the box here. Slide 2. Potential mechanical energy. All types of energy can be stored. Right? Remember we talked about the fact that energy is not destroyed, right? It's either made into one form or the other. When the energy is stored, we call it potential energy. Mechanical energy is a form of energy associated with the motion, position, or shape of an object. This type of energy can also be stored. Wind a clock. The clock spring stores the mechanical energy. We call stored mechanical energy potential mechanical energy. And that is the answer we're looking for our next post-it. So I'm going to underline that here. We call stored mechanical energy potential mechanical energy. So here I have put a horrible star here next to our definition. We call stored mechanical energy potential mechanical energy because our question at the top, what is potential mechanical energy? We call stored mechanical energy potential mechanical energy. So that's the answer you're looking for, stored mechanical energy. When the clock begins to run, the stored energy is then released, allowing the clock to move. This energy is what makes the clock work. So basically, if you're winding a clock, and these are those old school clocks, so if you're looking at the back, right, you kind of wind it. You're thinking, okay, it has the ability to move once you let it go and the clock starts to run and it's tick, 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 ticking, then it will start to move, right? So it's stored potential, so potential mechanical energy. It can move you're winding it up, you're getting it ready to do so. Okay, so that's the definition we're looking for here. All right, let's move on to slide 3. Energy from gravity. So, gravity is the force that attracts all objects to the center of the earth. We did talk about last year, right, the fact that when you have gravity pulls everything to the center of the earth, right, we're not floating, we're walking along the ground, right, is the fact because gravity is underneath of us, right? It's in the core of the earth, right, the crust, the mantle, the core. So it's in the core of the earth, it's pulling everything down. So let's continue. Any object that is raised off the ground has potential energy. When the object falls, the energy is released. The stored energy is being converted, meaning it's being changed to moving energy. When a falling object hits the earth, it releases energy as sound and heat. Falling water can turn a wheel and produce mechanical energy. Things that can fall have potential gravitational energy. So where can you find potential gravitational energy? Well, they just told us here, right? They gave us a little bit of a hint. Let's change our color, maybe pink here. So it says, where can you find potential gravitational energy? Well, falling water can turn a wheel and produce that mechanical energy. And then things that can fall. So something that can fall have potential gravitational energy. All right, so when you're looking at your question, where can you find potential gravitational energy? Things that can fall, right? And that's what we're looking for here, and you can put your answer right here. All right, let's continue. Elastic potential energy. Due to shape, there is another type of energy. It is called elastic potential energy. This type of energy is associated with objects that are stretched or compressed. A rubber band is a great example, right? So think of a rubber band. You can pull it, right? And it can kind of hold it still. So it's elastic. You can pull, but it's also potential because you can hold it and it won't be moving. As you stretch the rubber band, it changes shape. This shape also increases the amount of elastic potential energy. When the rubber band is released, the stored energy sends the rubber band flying into the air. Okay, so you're storing the energy, right? You're going to store that energy, and then all of a sudden, when you release it, right, it can move, but it's stored up, right? You're making it stretch, and then it's stored. So they're asking us here, what is elastic potential energy? So let's think about that. What is elastic potential energy? And at the top, there's some sentences here that talk about it, right? It is called elastic potential energy, but what is? So let's underline. I'll use some green this time. This type of energy is associated with objects that are stretched or compressed, right? So meaning they're stretched out, they're compressed, meaning they can move, but they're not moving. Remember, potential is not moving. So what is elastic potential energy? We're going to use this sentence here. Is the energy that's associated with objects that are stretched or they're compressed. They're not moving, but they are stretched out. All right. We'll go to slide 4. Kinetic energy. So we said potential means you're not moving, right? Kinetic is movement. So let's start reading here. We know that objects that still have potential energy, moving things also have energy. The energy in moving things is called kinetic energy. Okay, so energy that is involved with moving things. When moving things are stopped, the kinetic energy is changed back to potential. When you catch a ball, the kinetic energy of the ball is changed into heat and sound. The faster things move, the more kinetic energy they have. In baseball, a line drive has more kinetic energy than a pop fly. Right, a line drive goes very quickly off the bat, makes that sound, and quickly flies into the air, right? And a line drive usually goes quickly to someone else. Many times they're going to catch that baseball. So it is moving quickly, has more kinetic energy. A pop fly, yes, it's going to hit off that bat, but it's going to slowly, right, go into the air, and it's not moving as fast. Things that are not moving have no kinetic energy. They have potential energy. So if it's not moving, it's potential. If it is moving, it's kinetic energy. So here's our question. What is kinetic energy? Right? And here at the top, we have that definition. Let's find our pen. Here we go. Let's use back to red. The energy in moving things is called kinetic energy, right? And so we are underlining that because we're looking for the definition of kinetic energy here, okay? Let's scroll up to the top here. Factors that affect kinetic energy. So what can affect the fact that something is moving, right? Can anything make it that movement change? Moving objects have kinetic energy, but the amount of energy they have depends on a few factors. The amount of kinetic energy in an object depends upon its speed and its mass, right? So how fast it's moving and the amount of space it takes up. If you think about the baseball example above, if you were hit with a line drive from a baseball, it would hurt a lot. However, if you replace the baseball with a foam ball, it would not travel as fast and it would not hurt at all. This is because the foam ball does not have the same mass as the baseball and would not travel at the same speed unless more force was added. Okay, so basically, the heavier something is, the bigger that it may be, the faster that it's moving, that means the more kinetic energy it will have. So thinking that way, which has more kinetic energy? This question at the bottom, a bird or a plane, and why? So let's talk about that. What do you think? So let's talk about that. Which has more kinetic energy, a bird or a plane? So remember that what we set up here, speed and mass, right? So which one's going to travel faster, a bird or a plane? Okay. Which one, we're talking about mass, which one has more weight to it, right? And hitting you would be much more dangerous. So which one has more kinetic energy? You're going to put your answer in this text box here. Okay. Then we have one last slide here, slide 5, and this is where we're going to check our understanding here, guys. Okay. So here's what we learned. Stored energy is potential energy. Stored energy comes in different forms depending on its height or shape. Moving energy is kinetic energy. The amount of kinetic energy depends on the object's speed and their mass. So here's the comprehension check. So let's see what we understood. 1, a car sitting at the top of a hill is an example of which type of energy? It's at the top of a hill. It's not moving. What type of energy is that? Write it down here. Number 2, sliding down a slide is which type of energy? You're moving. Which example is that? Remembering, if you're not moving, it's potential. If you're moving, it's kinetic. 3, a trampoline waiting to be jumped on. Nothing is on the trampoline. No one is on the trampoline. It's just still. Is that potential or kinetic? 4, a football being held in your hand has which type of energy? You're not moving that football. You're holding it. You can move, but you're not. You're just holding it. So if you're not moving, is it potential or kinetic? Remember, potential, you're not moving. 5, a match waiting to be lit has which type of energy? Not moving. It's waiting to be lit. It's still. 6, a lit fire has which type of energy? The fire is moving around and warming up. Is it potential or kinetic? 7, which has more potential energy? A person waiting to go down a roller coaster or a plant sitting at the top of your kitchen table? So remember, Potential means it's not moving. Which one has more potential energy? Which one is higher up? Right, a roller coaster is really high in the air. Plant sitting on your kitchen table, it has the potential to move, but it's not. Which one is higher and takes up more space? That one has more potential energy. 8, which has more kinetic energy? A football player running down the field or a baseball player throwing the ball to home plate? So which one is moving faster and then taking up more space? So that answer you're going to put here. You're going to put the baseball player throwing the ball or the football player running down the field. So any questions, please let us know, and make sure you're answering all those questions here where you see insert text.